Humanity is standing at the threshold of one of the most intriguing moments in modern astronomy, as scientists prepare to focus their analytical power on an interstellar object unlike anything we have encountered before. The strange visitor, officially named 3I/Atlas, has captured the imagination of researchers and the public alike, not only because it represents the third confirmed interstellar object to pass through our solar system, but also because it refuses to behave like any ordinary comet or asteroid. NASA is now poised to release the sharpest and most revealing images ever taken of this Manhattan-sized traveler, and expectations are soaring that these pictures will finally push the discussion surrounding its nature from speculation into concrete scientific understanding. The images were captured by the Mars Reconnaissance Orbiter's HiRISE camera during the object's passage near Mars between October 1st and October 7th, a window of opportunity that allowed researchers to photograph it from a vantage point far beyond anything Earth-based telescopes could provide. Though the photos were initially delayed due to the recent U.S. government shutdown, NASA has confirmed that they could be made public as early as next week, setting the scientific community abuzz with anticipation. For astronomers who have debated the object's composition, origin, and behavior for months, this release represents not just another data point, but potentially the first definitive step toward unraveling one of the greatest cosmic mysteries of our time. Until now, the best images available of 3I/Atlas were those obtained by the Hubble Space Telescope on July 21st, but scientists believe that these new HiRISE photographs will surpass them by a significant margin. Hubble's resolution, though powerful, is limited by its position in orbit around Earth, whereas HiRISE orbiting Mars has the advantage of proximity and a far superior imaging capability. The HiRISE camera is known for its extraordinary ability to capture surface details on Mars at astonishing sharpness, and in this case it provides roughly 3 times the resolution of Hubble when targeting distant objects. Researchers hope this advantage will allow them to observe subtle characteristics of 3I/Atlas that were previously invisible, including the structure of its coma, the behavior of dust streaming from it, and most importantly, the potential outline of its nucleus. Although scientists acknowledge that even HiRISE may not fully resolve the solid core of the object due to its immense distance and relatively small size compared to the surrounding dust cloud, the camera's unprecedented sharpness can still offer valuable constraints. As Harvard astrophysicist Avi Loeb noted, even identifying the brightest pixel within the blurred nucleus region could allow experts to estimate its diameter with surprising accuracy. For an object that has sparked heated debate and polarized opinions across the astronomical community, every pixel matters. The excitement surrounding 3I/Atlas stems in large part from the fact that the object exhibits behavior rarely, if ever, observed in ordinary comets. One of the most unusual features is the presence of what observers have dubbed an anti-tail, a stream of dust that appears to point toward the sun rather than away from it. This puzzling configuration runs contrary to the expected behavior of cometary tails, which are typically pushed outward by solar radiation and the solar wind. An anti-tail can occur under certain rare geometric conditions, but even then, the formation seen on 3I/Atlas is unusually pronounced and persistent. This has prompted some astronomers to argue that either the dust surrounding the object is behaving in a way not well accounted for by current models, or the object possesses physical properties and structural features that defy conventional expectations. Loeb, who has been vocal about his skepticism toward traditional explanations, has described the anti-tail as something not seen in everyday comets, suggesting that scientists should remain open to the possibility that 3I/Atlas is fundamentally different from natural interstellar debris. This is not the first time Loeb has positioned himself at the center of controversy involving interstellar objects. When Oumuamua, the first known interstellar visitor, swept through the solar system in 2017, Loeb argued that its unusual acceleration and flattening shape could indicate an artificial origin. Although many scientists disagreed, dismissing the hypothesis as premature or speculative, Loeb's willingness to propose unconventional explanations earned him both supporters and critics. Now, with 3I/Atlas presenting another set of anomalies, Loeb has again urged the scientific community to entertain a wide range of possibilities, including, but not limited to, the notion that the object could be technologically made. He has emphasized that extraordinary claims should be met with extraordinary evidence, and the upcoming high-rise images may either bolster or dismantle such theories. Even if the interstellar traveler ultimately proves to be a natural object, Loeb argues that examining it through multiple scientific lenses is essential for expanding our understanding of the cosmos. The debate has only intensified due to the delayed release of the images, which Loeb criticized as a frustrating example of bureaucratic inefficiency. In his view, withholding potentially groundbreaking scientific data due to administrative gridlock deprives the scientific community of timely insights and slows the pace of discovery. Others in the field have echoed similar concerns, noting that interstellar objects do not wait for government processes to resume. They continue their journey, offering only brief windows for observation before vanishing into the depths of space forever. For this reason, the eventual release of the high-rise images is being treated almost like an astronomical event in itself. Amateur skywatchers, professional astronomers, and the growing community of individuals fascinated by interstellar phenomena are all eagerly waiting to see what secrets the images may reveal. Whether the object turns out to be a strangely behaving comet, a fragment of a shattered exoplanet, a chunk of exotic material from another star system, or something that pushes the boundaries of imagination, the photographic data is expected to narrow down the possibilities considerably. The significance of 3I/Atlas extends beyond its mysterious behavior. It represents only the third known visitor from outside our solar system, following Oumuamua in 2017 and the comet-like 2I/Borisov in 2019. Each of these objects has presented astronomers with a unique puzzle, demonstrating how little we truly know about the materials and phenomena that populate the spaces between stars. Unlike asteroids and comets that originate within our solar system, interstellar objects carry chemical signatures, structural characteristics, and dynamical behaviors shaped by entirely different environments. They may have formed around other stars, existed through cataclysmic cosmic events, or drifted across vast distances for millions or even billions of years before crossing our path. In many ways, they are time capsules, physical relics from regions of the galaxy humanity has not yet explored directly. Studying them closely offers a rare and valuable opportunity to expand the boundaries of planetary science, chemistry, cosmic evolution, and even astrobiology. The arrival of 3I/Atlas has been particularly important for researchers interested in understanding the diversity of interstellar objects. Borisov behaved more like a traditional comet, exhibiting a predictable tail and fragmenting in ways consistent with icy bodies. Oumuamua, however, stunned scientists with its unusual shape, non-gravitational acceleration, and lack of a visible tail. 3I/Atlas appears to sit somewhere between these two extremes, part comet, part mystery, with its anti-tail and brightness fluctuations hinting at complex dynamics. Every detail captured by high-rise may help reveal whether the object formed through natural processes we already understand, or whether it represents a category of interstellar bodies we have never encountered before. As the world awaits NASA's release, the story of 3I/Atlas serves as a reminder of how rapidly our understanding of the universe can change with a single discovery. Just a decade ago, astronomers had no confirmed examples of interstellar objects passing through our solar system. Today, we have three, each raising profound questions about the origin of matter, the mechanisms that eject objects from distant star systems, and the potential for technological artifacts to travel between stars. Even the most conservative scientists agree that interstellar astronomy is still in its infancy, and the more data we gather, the more surprises we are likely to encounter. The high-rise photographs represent far more than just visual evidence. They are scientific milestones illuminating a frontier we have only begun to explore. In the coming days, as the images are finally revealed, the global scientific community will scrutinize every pixel, every shadow, every faint trace of dust streaming from the interstellar visitor. Some will look for confirmation of natural explanations, others will examine whether the anomalies can be dismissed, and still others will search for clues that challenge our existing frameworks. Regardless of what the images ultimately show, the release will mark an exciting moment in space exploration, one that reminds us of our deep curiosity about the universe and our eagerness to understand the unfamiliar. 3. I/Atlas, with all its strange features and unanswered questions, has become more than just an object passing through our system. It has become a symbol of humanity's enduring desire to seek truth amid the stars.